Welcome, new children, those who are going to grade 11 to study science and especially chemistry and physics alongside. You will be requiring some knowledge of finding out atomic weights and their calculations. So here is a video which I have made to make the things easy for you. The atomic weights were as early as 1800s noticed by the scientists Pierre Louis Dulong and Alexis Therese-Petit. When they noticed that the product of an element's specific heat and its atomic mass was roughly a constant for many solid elements at room temperature, they arrived at the law, which is the specific heat into the atomic mass of an element is roughly 6.4, where C is the heat capacity and M is the atomic weight of or atomic mass of the element. 6.4 was found to be a constant. But this is only an approximation and is true for only certain elements. It is not true for all elements. The given relationship holds good for some simple elements only. This is because very high and low temperatures affect the vibration of atoms. It also assumes equal contribution from all elements to specific heat capacity, which is not true. We can calculate atomic weight or average atomic weights from isotopic masses and their abundances. So if a more precise value of atomic weight of an element is to be calculated from the abundances and atomic weights of different isotopes of the element, we apply this formula: average atomic weight or average atomic mass of isotope 1 into abundance of isotope 1 plus atomic mass of isotope 2 into abundance of isotope 2, and so on if there is a third isotope, and so on if there is a fourth isotope, divided by 100 gives you the average atomic mass of the element. Chlorine is one great example. Oxygen is also a good example. Carbon 12 and carbon 14, they are very good examples. H1, H2, and H3, H11, H21, H31, they are also a great example of this. This method is based on mass spectrometry. The atomic mass can be calculated using the formula atomic mass equals molecular mass of the element, and N is the number of atoms per molecule. Remember, this is to be applied in case of diatomic, triatomic, tetratomic elements like ozone, sulfur, phosphorus. So we apply this formula. It is done for you. Sulfur is represented as S8. It is an octatomic molecule. The atomic weight of or the atomic mass of 1 is the molecular mass of sulfur, which is 256 divided by 8, because 8 is the number of atoms per molecule, and it gives us 32. The easiest of all the method is by looking up a periodic table. In exams, periodic tables may not be given. Certain examinations give periodic table. IB gives periodic table. IGCSE gives periodic table. A part of periodic table may be given in ICSE or in ISC examination also, or the values may be given. But if a numerical is based on this, then these things may not be there. So you have to use the formula which we have dealt with, in the previous slide, it's Dulong-Petrit's method, or by calculation from abundances of different isotopes of an element. The actual weight of an atom can be calculated by the ratio atomic weight of the element divided by 6.022 into 10 to the power 23, 10 raised to 23. That gives us atomic weight of one atom. And that is what is meant by atomic weight. Atomic mass can also be calculated from the formula equivalent weight into valency. If equivalent weights are given, valency of the metal is known in a particular numerical, we can find its atomic mass, and by using the formula atomic mass equals equivalent weight into valency. Remember, atomic weight is nothing but atomic mass expressed in grams. The numerical values are same. For atomic mass, we use the units A and U. For atomic weight, the same numerical value has a unit of gram. The most recent method of finding atomic weights as well as molecular weights is in comparison with 1/12 of an atom of carbon-12 isotope, which is actually the mass of one proton. Roughly the mass of one proton, because there are neutrons also, and we consider that the mass of proton and a neutron are almost equal, if not exactly equal, and can be substituted for either. The reasons for choosing carbon-12 are as follows. Carbon-12 nuclide has a whole number mass of exactly 12 AMU, and this ensures consistency in calculation of atomic weights, and therefore H11 and oxygen 16 are now abundant. Earlier we used to have H11, that is hydrogen, and oxygen also, you see, but now it has been abundant because of these two reasons, that carbon-12 nuclide has a whole number mass of exactly 12 AMU, and using this ensures consistency in calculations of atomic weight. Children, you will have to solve problems using these, which I haven't done in this video. This is to tell you in a nutshell that these are the methods that you will be using in calculation of atomic masses if a numerical is based on it. And these are the 6 or 7 methods that I have just enumerated, with some history behind it and some logical reasoning behind it. Thank you for watching. Please do subscribe and comment and ask questions. Thanks a lot.